Hello everyone. In this session of CCNA series, I will do a lab on floating IPv6 static route. And for this, I have a scenario where I have a WAN router connected to two different ISPs to reach internet. And we have a server hosted on the internet. So as you know, as we discussed in the floating static route with IPv4, a company or a branch office, if it needs to have a primary and a secondary connection to reach any server in the internet. For example, why do we need primary and secondary connection? Because if you lose the primary connection, the traffic will be shifted to the secondary connection. So there is a backup. Okay, it is for a backup purpose. So when you lose the primary path, the traffic will be shifted to the less desirable secondary path. The primary path will have a better speed or higher bandwidth, and the secondary path, since it is used only when the primary is down, will use less desirable, less bandwidth or less speed. So similarly, I have two paths here. One is primary, which is using OSPF, and the secondary path, which is using static. Now, there is a situation, as you know, for this my WAN router to reach this remote server, if it has a path through OSPF and another path through static route. So by default it will always choose the static path, but this is not our primary path. So this is where the floating static route comes into picture. A floating static route is something when you have two multiple paths using different protocols, we will increase the administrative distance of static route, which is by default 1, to something higher than the administrative distance of the OSPF. OSPF has an administrative distance of 110 and static route has a administrative distance of 1. So if I increase the static route administrative distance to 111, it will become a floating static route, because when the OSPF neighbor goes down, this static route will become active. So let's go ahead and do the lab. For that, I will show you first. On the WAN router, currently I have, if you check in the routing table, I think I have already configured, no, what, let me check. Oh, this is a remote server, sorry. If I log in on to, okay, the WAN router, you see the static route is taking precedence because its administrative distance is .1. And if you see, it is reachable via 2001:1, which is my secondary router IP. Okay, so let's go ahead and increase the administrative distance of, and before that let me show you, I have already a neighbor, IPv6 neighbor via FA0/1, that is through my primary link. So let's go ahead and increase the administrative distance. So for this static route, let me increase the administrative distance to 111. So what will happen is, now if you check the routing table, the remote server IP is reachable via OSPF. With this, you can confirm it is going through the primary link, and even this will show you FA0/1. Okay, you can do a trace route and see as well. It should go via 2002. As you can see this server is reachable via 2002 double colon 1, which is the IP of the primary server. So now we need to test the fallback in case if the OSPF neighbor goes down. So it should fall back to the static route. This is where we are testing the floating static route. So let me go ahead and shut down the neighbor. This should fall back to the static route. If you check my static route now, still it is with OSPF. Let me check. Now it has fall back to the static route. But if you see, the important thing is the administrative distance is showing 111 now instead of default 1. And if I return the link back, it should go back to the primary link again. Let's wait till the OSPF neighbor comes up. It will fall back once the OSPF neighbor is up. Still in two-way state. Is the next start now? Okay, now I have, let me see, still okay. So once the OSPF neighbor is in full state, you will see the route available via OSPF. That's it for this session. I hope this was informative for you. If you have any comments, please do share. I'll be available to reply to you or clarify your doubt. Thank you for watching.